In this video, we'll look at the nomenclature for carboxylic acid derivatives. So there are a lot of carboxylic acid derivatives. There's 4, and we're going to learn how to name them each individually. And for naming purposes, I want you to be able to name simple derivatives. We're not going to do anything crazy where there's more than one kind of derivative on the same compound. So we'll start with esters. So generically speaking, this is an ester, and the way that we name esters is alkyl alkanates, generically. And this R group coming directly off the R is the alkyl substituent, and whatever the R prime group is that comes off of the carbonyl, that's the alkanate part of the name. So we'll do a specific example on the next page. So for example, we could have this guy. So coming off of the oxygen, we have our alkyl group, and then this will be the other side. So they're both 2, so I could call this ethyl ethanoate. So instead of the E on the end, the O8 tells me that I have an ester, and the first part tells me what's coming off of the oxygen. Commonly, this group right here is called an acyl group, or acetate, and so the common name for this is ethyl acetate. So you might see acetate, and when you do, that's referring to this group right here, this guy, with the carbonyl carbon and then one methyl coming off of it. So this functionality that the green arrow is pointing to is an acyl group. It's commonly called acetate when we name for common names. We'll do one more example. So remember from before that this group here is a phenyl group because it is just the phenyl coming off of there, just the benzene ring. And here I have another carbon, and so this would be a benzyl group. So the name for this guy is phenyl benzoate. Okay, so instead of benzene, we have benzoate, which tells us that we have an ester. And then, because that's the second part, we know that we have to have a carbonyl coming directly off that. We know that the oxygen has a phenyl group coming off of it. Next up is amides. And amides, generically speaking, look like this. So we've got a carbonyl, and next door we have a nitrogen, and I have 2 R groups on there. Those R's can be carbons or they can be H's. If they are carbon groups, then we use N as a locant. I'm going to make them R primes. I'm going to say for R prime. Okay, so any alkyl group that's coming off of the nitrogen will have an N instead of a number in front of it. So then we know that it's coming off of the nitrogen. So let's look at an example here. We'll do this N-methyl coming off of that guy. So we have 1, 2, 3, 4, 5. So that's going to be our longest chain there. And then we have these 2 methyl groups coming off of this nitrogen here. So it's going to be dimethyl. Those are substituents coming off of the nitrogen. So the way that we would name this would be N dimethyl, so that tells me where my 2 methyl groups are. They're both on the nitrogen. And then it will be pentanamide. So the word amide replaces the E at the end of pentane. So we know we have a 5-membered long chain. The amide tells us that it's an amide, and then we know that we have substituents coming off of the nitrogens, and we've used N's as locants for those, so we know they're coming off the nitrogen. We do this in alphabetical order, but in this case, both methyls, so no need to alphabetize that. For one more example, let's do that. So we have 1, 2, 3, 4, 5, let me add one more so it's not exactly the same, 6, so a 6-membered long chain. And then we have substituents here. We've got an ethyl group, and a methyl group. And so I will alphabetize those substituents, so E comes before M, so the ethyls will become first. And when you have two locants and one of them is a nitrogen, the N will come first. So this will be N3 diethyl N methyl, and then I'm going to swing around, but these would be connected, hexenamide. So this guy is N3 diethyl N-methyl hexenamide. So we know that we have two ethyl groups. One's coming off the nitrogen, one's coming off the carbon 3 in my main chain, and then I have another methyl, and that's coming off the N, which is being used for a locant. Next up we have anhydrides. So an anhydride is like two carboxylic acids stuck together minus the water, so that's why it's anhydride, hydride being for water. So these guys are named something anhydride, and if they're symmetrical, like let's do an example here. This guy has 1, 2, 3 carbons and 1, 2, 3 carbons, so this would be called propanoic anhydride. So it's two separate words because we know it's an anhydride and there's only one descriptor out in front there, propanoic, then we know it has to be symmetrical. So if it is symmetrical, you put the name of the groups coming off of that middle oxygen and then the word anhydride. You could have an asymmetrical anhydride, and if that's the case, we just name each one and we put them out in front in alphabetical order. So this would be butanoic, ethanoic, anhydride. So there's three words there, three separate words, butanoic, ethanoic, anhydride. We know it's an anhydride, so it's got an oxygen in the middle with two carbonyls coming off. The butanoic and the ethanoic tell us how many carbons are in each of the two chains. And then I just put them in alphabetical order, so B becoming before E. Lastly, we have acid chlorides. And you can have more than just acid chlorides. You could have acid bromides or fluorides, but the most common one we see is an acid chloride. So generally speaking, we're looking at this guy. So as an example, let's look at this. I have 1, 2, 3 carbons. The acid chloride, again, is going to have to be terminal because that chlorine can only make the one bond, so it'll be on the end there. This guy is called propanoyl chloride. 2 words. So the root name is changed as this OYL, and that tells us that we have an acid chloride. If it was a fluoride, it would be propanyl fluoride or propanyl bromide if we had a bromine in this position right here. So we can do an example of that. So let's do a bromide, and let's put a bromine on this as a substituent too. So we've got 1, 2, 3, 4. So this is going to be butanoyl, and then it has a substituent on it. So this would be 3 bromo butanoyl and then bromide because I have a bromine there instead of a chlorine. Lastly, if I have a cyclic system with an acid chloride coming off of it, I put the entire name of the cycloalkyl group in front of carbonyl chloride. So this would be cyclopentane carbonyl and then space chloride. So for cyclic groups, you put the entire name of whatever the cyclic system is, followed directly by the word carbonyl. So that's one word there, cyclopentane carbonyl space chloride. So as you can see, it's a lot of information about naming, and what I'll expect you to do is to be able to name basic derivatives of carboxylic acids, such that you could work a problem if they give you a name of a simple derivative. I'm not going to have you name anything really crazy. I'm not interested in your ability to do that because that's kind of a lot of memorization to do that. But you do want to be able to work intelligently with the nomenclature such that you can understand what's going on.